Hello and welcome to another coding ASMR video. I am actually, for once, continuing a project. This is basically a first for me. But if you were not here for the last video, don't worry, we're just going to do some chill coding. And you haven't missed much. We'll do a quick recap. So I'm still working on my local RAG video project, which stands for Retrieval Augmented Generation. That's an AI thing. You save documents to a database with embeddings, and then when you ask your AI chatbot a question, it first looks up the documents in the database and then tries to use them for a better answer. So I'm doing this mainly for learning purposes, and in the last episode we created this notebook, IPyNB, and we used OpenAI for now. Of course that's not local, but the database is local at least. And initiated a client after some back and forth, and then we used Markdown IT, Markdown it. I keep saying it wrong. And then we used the Markdown it library to check all the MD files. For now that's just 2 in my repository, and we go through them and re-extract all the headings and also the body, and then we join all of this together, and then we created a short summary using the chat completions API endpoint, saying summarize the following document in a short sentence. And then of course one of the most important parts is we created an embedding, also using OpenAI for now. We used the text embedding 3 large model and created an embedding response, and then we put all of this into a pandas data frame. This then looks like this. We have the title, what is outlier detection, and beginner tips for prompting, and then we get a summary that you can also see up here, just a 1 or 2 sentence summary, and the embedding vector, which I think is, if we re-execute all of this, I think that's actually 3,000 entries long, which is a problem for the rest of this. So data frame embedding, first entry, oops, and then let's output the length of this. Yeah, the embedding of the text embedding 3 large is 3,072 entries long, which is nice. It has a good performance, but it will not fit into our database. So that's one of the things we're fixing today. But I'm also using Cascade and the Windsurf editor, which enables me to use AI autocomplete and such. And we just covered last episode that it doesn't like to automatically fill in code in these notebooks. So as I was coding on my own time, I went over to using these Python notebooks. So you can use these cells if you type a comment and then 2% signs, it creates a cell, so you see all of this here is one cell. You see two faint lines here, and you see run cell. So that's actually what I did. And then let me restart this and clear this. So we have the output down here, and now we can say run cell, and it runs just this code in between the two lines and shows us the output down here. So that's also a notebook. It's debatable if you think it's nicer or not as nice as the IPython notebook, but it's a normal Py file, which means that it should work nicer with the write mode, which will automatically make changes to our code if we want to. Alright, so we've also set up a Postgres database using this Docker Compose file. We're using pgvector as a vector database. This is just my first try at doing this. I've already discovered that this has some limitations, but this is just the setup for now. What we're doing today is we're cleaning this code up. So you will see the bits that I did here, but let's actually start by this is basically just the setup. I think that's fine with me. We're creating the client, we're connecting to the database. These are just very simple local passwords. This is not deployed in the cloud, so yeah, of course you should change those if you deploy this, and then import these strings probably as an environment variable, but this is just local, so that's okay. Next up, as you can see here, I have changed this so it uses embedding dimension 1600. We can quickly jump into this file. So I put it into one big function for now. All of the code I've just went through. We check out all the markdown files. We parse them. We create a summary and an embedding, but we restrict the dimensions to 1600 because that's the maximum for pgvector. And then this returns a data frame. So that's good. Next up, we do all of these SQL statements, but they're all just in one unwieldy step here, so I want to have a few functions for this. So let's do this like this. I guess we keep the import statements in its own cell, but then we do def and we create a function, just setting up the table, I guess. So let's call it setup embedding table for now, and I believe it needs the connection. Yeah, I don't know if we can use the cursor multiple times. I haven't quite understood. You can close both of them. I'm not sure what the best procedure is for this yet, but let's pass the connection, which will be probably this, and then create a cursor. You need to run this once at the start. I guess we do this in this as well. This is just for enabling the vector data type and the accompanying functions and functionalities. Next up, we create the table. Adjust the dimension based on your actual embedding size, so we need to pass that as a parameter. Wait, I'm not sure what the direction is. This, probably. So our table will just have ID, title, content, and then the vector with the appropriate dimension. And then we close the connection again. Oh, I forgot to copy paste the closing parentheses apparently. Wait. Oh. Of course, there is no parentheses at the end of the function. I think it got misplaced. Okay. So now we can delete this. And we can replace this by saying set up embedding table with the connection and the embedding dimension. Beautiful. And then the next thing is inserting all the documents. I think I actually want to delete the table if it exists. Just to make sure it's clean. Right now, after we did this, after we professionalized this a bit, of course we don't want to delete everything all the time, but for now this is just easier. So we don't get like duplicates all the time. So then we want to insert all of the documents from a data frame. So that's another function, def insert embeddings, get a cursor, and then index row from the embeddings data frame, insert into documents, title, content, embedding, string, 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 row, title, content, embedding. Yes, I think that's right. I'm not sure if this is supposed to go in as a string, but we'll figure it out. Connection commit. Oh, should I be doing this? Oh, I did do this. Should I be doing this here as well? I wonder. I should really look into this. Maybe we ask AI in a little bit, but I want to finish this function first. So we then need the pandas as an import. Right, import pandas as PD. I think the index is actually not used, so we can just use an underscore. That's like a sort of Python hack-ish. If you don't need a return, like if this returns two variables like the row does, it returns the index and the row, and if you don't intend to use one, if you keep it like this, it will always be like, hey, this variable is never accessed, and it like confuses people who read your code. It's like, where is this used? What do you need this for? And if you call the variable this underscore, it sort of signifies that you don't intend to use it. It just a placeholder because you need to accept 2 entries. But yeah, you will never use it. And then this can be used here. And then I also have just a little bit of code that fetches all the documents and prints them. So I guess the last function we will create up here is fetching all the documents. But for now, I actually dislike all the empty spaces around here. I think this is a little bit better. Okay. Def print db contents connection, get a cursor, execute a select, cursor fetch all. And then print the rows. Okay. If AI says that, we'll just believe it. And then print everything. And then at the end we close the connection. Okay, so let's try if this works actually. Let's clear everything, restart the kernel just to make sure everything is restarted, and then we run the imports. Everything worked. Then rerun all the function definitions. That's also fine. Nothing was executed yet. Then rerun the connection and getting all the embeddings. Embedding dimension is correct. Now let's set up the table. Okay. Insert the embeddings and let's see if it worked. Yeah, we get index 1, what is out there detection. We get the summary, and then we get a very long vector which should be 1600 entries long. Now I've already stumbled over this, but this, if you fetch it, it's a string again. So saving it into the database and retrieving it makes it into a string. So if you want to do something with it outside of the database, you need to transform this again into a vector. But for now that's good. Let's close the connection. Okay, this looks good. Now what's next? I actually put down some notes last time. I want to create embeddings and decide on the data structures to store them. We did that. We also already did part 3 of setting a Docker container, and then we didn't enrich a query yet, and we haven't queried the knowledge base yet, so I guess this would be our next function. With a connection and a query, we of course need a cursor, and then what in the heck is going on here? So this just suggests select from documents where embedding. What is PLV8? Okay, can you let's ask the AI what the heck it thinks it's doing. I don't know why this is there. I don't like it. Okay. Alright, so So here's the embedding at add PLV8. It selects all columns from the document table where the embedding column matches a certain condition. A Postgres specific operator for full text search of vector operations. PLV8 is a procedural language extension which allows for JavaScript execution. However, in this context, it seems to be used as a placeholder or an arrow in the snippet. I also think this is an arrow. I don't know what this is. Okay. We need to embed the query. We actually need the OpenAI client. Like this. I think it's learning from our other file. I actually would prefer if it used this though. You then get the embeddings create with the input string, text embedding 3 large, dimensions 1600, embedding vector, embedding response data. Okay, and then we return the vector, which is a list of floats. So I should put this here. Okay, and then we use this here. So query embedding, call the other function. This also means we need to pass the client here, pass it along to the other one, and then we get the query. And then how do I find the most in the Postgres PG vector? I think there was exactly, you use this operator with the arrows, but I think that's cosine similarity. Okay, so AI says to find the most similar embedding using the PG vector extension. You can perform a nearest neighbor search using the arrow operator. This operator calculates the distance, and then we do select where, you order by, and then you limit by 1. Okay, and then this could look like this. I don't know why it's doing that. Does this mean we see this as a vector? When you execute the query, you pass the actual value. It's a typecast in Postgres. It tells Postgres to interpret the value as a vector type. Well, let's see if this works. I dislike how this is formatted, but I guess it's fine. Actually, I think I would like it like this. Maybe, and then maybe this. Yeah, maybe this is nicer. Okay, then you put the query embedding here, and then fetch 1 and return the result. Okay, that's nice. I suppose. Then probably need the connection again. I should probably separate this here so we can just run this again to get the connection again, and then make sure this is still working. Okay, it is. Let's see what this is returning. Theoretically, none of them are very close. What is a vector database? Is neither close to outlier detection or beginner tips. So this will be interesting. Of course, I need to run this cell up here again. And then we can run this, which uses the new function that we've just written. The closer one is what is a vector database. Now let's use what is prompting, and it will return the beginner tips for prompting. I mean, this has basically the word in it, but how do I use AI for my day-to-day tasks? Also the beginner tips for prompting. So that's nice. I think it's working a little bit. I think one of the things that I actually need to check is the chunking. Right now, the embedding inputs might literally be too long and get truncated. So we need to chunk them. That's correct. Thank you. AI autocomplete. Implement the chunking. Well, yep, that's implement the query. No, that's fine, thank you. Okay, but I think we will pull this back to a future session. Now we did part 4, use the vector storage to query the knowledge base. That's good. And then we should use the embeddings to enrich a query. So query the DB, you get the result. The result consists of the document title, but that's not the file name, so I guess I should keep the file name. But if I put the file name here, I will need to parse it again and use the markdown processor again. Right now this is all in one. Should probably pull this apart as well. Write mode, add file, markdown processor. First one being taking a markdown file path and extracting the content into a string. The second going through all those markdown files and creating embeddings and summaries for them. Let's see if this can restructure this for us. Create two separate functions, extract markdown content, process markdown files. Yes, that would be nice, thank you. It's always a bit hard to read. Okay, extract markdown files, markdown content, open, file read. That's not exactly how I envisioned this. Extract markdown info. Oh, I think it created 3 functions actually. That's fine. Okay. We read all of the file, just file read, creates a string, and then in this one we get the content, extract to the markdown parsing, so to say, and return the headline and body. That's nice. Return a tuple, and then this takes the OpenAI client, gets all the markdowns, passing the markdown it is a bit weird, but I'll live with it for now. And then extract markdown content is called here for every file that we find. Oh, this calls the first function, and it's just a raw string, and then for every string we extract the info, which is the headline and body, and then we create a summary, and then the embedding, and then we append it here and return it. Nice. Okay, because what this allows us now is to use this part for actually retrieving the found content. Add the file name / path to the data frame and table. And then write a function to retrieve the file contents for the most similar embedding. Write function to enrich the query with the found content. Generate answer based on query and found context. Beautiful. So that's the leftover stuff that we should do to get the rough plan working. And then you might see on the left side that I also started on looking into local embeddings. I have this example code using the multilingual BGE M3 embedding model. I also need to check how I make those into a smaller dimension, because I think this returns 2 long vectors as well. But yeah, this can then give us similarities as well. But I also need to check if it works with cosine similarity instead of dot vectors, dot products. So yeah, this will probably also be a later project to incorporate this into our code. But for now, I'm happy with the progress that we made today, and in the next video we can get some more progress done. I'm not sure how I feel about this notebook. having every single call in a single cell right now. I'll probably combine a few cells for the next one, because we tested them now, and after testing them separately, I guess we can combine them, and then it isn't as disconnected anymore. So that's it for now. Thank you so much for watching, and I'll see you in the next one.